At a restaurant in the Japanese city of Shimonoseki, a customer orders a dish that can only be legally served by a chef with years of training and a government license. On the plate are thin, almost translucent slices of fish arranged in a pattern. A single bite can kill an adult within a matter of hours. And to this day, there is no cure for the poison. If the dose turns out to be a little too high, the person doesn't lose consciousness, but stays fully aware, completely paralyzed, while the poison shuts down their muscles one by one. And yet people pay enormous sums for this dish, line up for it, and travel to Japan specifically to try it. And by common estimates, the poison in a single adult fish is enough to kill about 30 people. This is fugu, a pufferfish, and an entire culture of controlled risk has been built around it. But this same fish has a far stranger relative, a tiny creature that Japanese divers found on the seafloor and couldn't explain for almost 2 decades. And when the answer finally came, it turned out to be far more touching than anyone expected. Here's something worth understanding right away. The deadly poison of the fugu isn't the only thing that makes this fish remarkable. And there's a question here that applies to you personally, even if you've never been to Japan and have no plans to try fugu. Why are people willing to pay for risk with pleasure? And why does that tingling sense of danger sometimes get valued more than safety does? Fugu might be the most extreme example there is of a person voluntarily signing up for closeness to death in exchange for a few seconds of a very particular taste. And here's a second question, an even more unexpected one. What if the creature we fear the most isn't what it appears to be at all? What if, behind the reputation of one of the most dangerous creatures in the ocean, there's a relative whose main occupation in life isn't poisoning enemies, but building extraordinarily intricate works of art on the ocean floor, for love? To answer both questions, we first need to figure out where the fugu's deadly poison actually comes from, and why people, knowing all of this, have kept sitting down at the table with this fish for hundreds of years. The relationship between people and fugu in Japan isn't just about food. It's a genuine tug-of-war between prohibition and desire. And in the 16th century, the warlord Toyotomi Hideyoshi, who was unifying the country through a series of wars, ran into a problem. His soldiers kept dying one after another from fugu poisoning, prepared in makeshift field conditions by people without the proper skill. Hideyoshi issued a direct ban on eating the fish within the army, one of the earliest documented cases of Japanese authorities stepping directly into what people could and couldn't eat, specifically because of fugu. The ban tightened and loosened over the centuries, but it took until the late 19th century for things to genuinely shift. And here's why. In 1888, in that same city of Shimonoseki, a prominent statesman of the Meiji era, Ito Hirobumi, was staying at an inn where the innkeeper, having no other dish to offer because of a storm, took the risk of serving him fugu anyway. He liked it so much that he personally pushed to have the ban on preparing the fish lifted in that region. And from that point on, Shimonoseki became the unofficial capital of fugu culture in Japan, a city where this fish stopped being just food and became a symbol of both skill and risk at once. But lifting the ban didn't mean removing the danger. And that's exactly why, in modern Japan, a chef who wants to legally prepare and serve fugu has to complete official training, pass an exam, and obtain a government license. The training stretches over years and covers not just cooking technique, but a detailed study of the fish's anatomy, exactly where in its body the poison concentrates, and how to safely separate it from the edible parts. This raises an obvious question. What actually makes this fish so dangerous that an entire licensing system had to be built around serving a single dish? The answer isn't in cooking at all, it's in biochemistry, and it turns out to be stranger than you might expect. The toxin that turned Fugu into a legend is called tetrodotoxin. Popular science sources often cite it as roughly 1,200 times more lethal than cyanide by weight. That's not a strict laboratory constant, more of a rough comparison, but it gets the scale across well enough. A dose the size of a grain of salt can kill an adult. Tetrodotoxin blocks sodium channels in nerve cells, the microscopic gates that electrical signals pass through to make muscles contract. And when those channels are blocked, the signal from the brain to the muscles simply doesn't get through. The person usually stays fully conscious the whole time. The poison doesn't touch brain function directly. It shuts down the body's ability to move, including, in severe cases, the muscles that control breathing. And that's exactly why tetrodotoxin poisoning is one of the most frightening scenarios in toxicology. A person can hear and understand everything happening around them while being completely unable to move. There is still no specific antidote for tetrodotoxin, and the only way to save someone who has been poisoned is to keep them alive artificially, usually with a mechanical ventilator, until the body clears the toxin on its own. If a patient gets that support in time, their chances of survival rise significantly because the toxin itself eventually breaks down and leaves the body. But here's what really changes the picture of this fish. Tetrodotoxin isn't produced by the fish's own body, and if you trace Fugu's genetics, it doesn't carry the genes needed to synthesize this substance. The toxin is made by symbiotic bacteria, mainly certain species from the genera Pseudomonas and Vibrio, which live inside the fish and get there through the food chain. Fugu eat mollusks, starfish, and other small organisms that already carry these bacteria, and the toxin gradually builds up in the fish's liver, ovaries, and skin. This has been confirmed experimentally. When researchers raised Fugu in controlled conditions, on a diet completely free of any toxin sources, the fish grew up entirely safe, without a single trace of tetrodotoxin in their tissue. So the deadliness of Fugu comes down to a specific diet and a specific set of microbes that the fish accumulates in the wild over its lifetime, rather than being something built into the species from the start. There's an important caveat worth flagging here. Among Fugu enthusiasts, and in some sources, there's a popular belief that skilled chefs deliberately leave a tiny dose of poison in the dish for a faint tingling sensation on the lips and tongue. It's a nice story, but most licensed chefs and Japanese regulatory authorities insist on something different. Properly prepared Fugu should be completely free of toxin, no exceptions, and any lingering tingling that some diners describe is more likely tied to other ingredients in the dish, or to the psychological effect of knowing you're eating a potentially deadly fish, than to any actual poison. Either way, the fact that people so readily believe the controlled dose version says a lot about how deeply the idea of risk is woven into Fugu culture. This fact forces a rethink of what Fugu actually is, an ordinary fish that adopted a biochemical weapon from its neighbors in the ecosystem and turned it into its own defense, rather than some uniquely genetically deadly creature. The poison turns out to be something the fish accumulated from the outside world, not something intrinsic to what it is, which raises the next question. What is Fugu, really, once you take the toxin out of the equation? The answer is waiting in a far more unexpected place, not in a restaurant, but on the ocean floor, where a close relative of Fugu uses that same defensive biology in a completely different way. By some accounts, in 1995, divers exploring the seafloor off the coast of Amami-Oshima Island in southern Japan came across something they couldn't explain at first. On the sandy bottom, a few yards down, lay a perfectly symmetrical geometric pattern. A circle roughly 6.5 feet across, covered in concentric grooves and radiating lines, as if someone had drawn it with a compass and a ruler. Nearby, they found several more circles just like it, each one unique but just as precisely made. The discovery quickly picked up theories. Some assumed it was the trace of some unknown underwater phenomenon tied to currents or seafloor geology. Others, half joking and half serious, started calling them underwater crop circles, the same phenomenon people had been debating for decades on land, only now underwater. Divers and researchers kept coming back to these circles again and again, but whatever was creating them stayed elusive. The patterns seemed to appear on their own, and no one ever caught the maker in the act. The mystery held for almost 2 decades. Everything changed once researchers finally managed to film the entire process of a circle being built, start to finish. And it turned out the architect behind these underwater masterpieces wasn't some mysterious natural phenomenon at all, but a tiny fish, a miniature relative of Fugu from the same pufferfish family, only about 5 inches long. Scientists later gave it an official scientific description and name: Torquegener albomaculatus. This is where the most unexpected part of the story begins. The circles turned out to be the result of incredibly painstaking, deliberate work by a single individual. A male that spends several days alone building this intricate structure in the sand, moving around one central point as if it were an axis, carving grooves with his fins without stopping. This wasn't some accidental byproduct of the fish's daily life, as some of the early theories assumed, but purposeful construction. So why would a tiny, poisonous fish, a distant relative of the very fugu served in restaurants in Shimonoseki, spend days of its life creating a perfect pattern on the ocean floor, one that the next strong storm will wash away? The answer turned out to be far more human than you'd expect, from a creature whose relatives are associated almost entirely with death. Once researchers finally got the chance to observe the whole process from start to finish, it turned out that a male Torquegener albomaculatus builds his circle almost without stopping for 7 to 9 days straight. He beats his fins, lifting and redistributing sand, shaping alternating ridges and valleys that radiate out from the center like spokes on a wheel. And the work is so demanding that by the time construction is finished, the male has noticeably lost weight and strength. The purpose of this structure is to attract a female. Female Torquegener albomaculatus choose their partner specifically based on the quality and precision of the pattern. The smoother the ridges, the more symmetrical the design, the better the male's odds of mating, and it's a form of architectural courtship, where craftsmanship is essentially what decides reproduction. The deciding factor is skill at building, not physical strength or size. But the circle has a second, far more practical function that researchers didn't notice right away. The fine particles of sand and shell dust that the male carefully arranges in the center of the pattern create a softer, more sheltered spot, exactly where the female will later lay her eggs. The grooves radiating out from the center, meanwhile, appear to affect how bottom currents move, scattering and weakening them, so that the fragile eggs at the center stay in relatively calm water and don't get swept away or buried under drifting sand. And the pattern works as both a decorative signal to the female and an engineering structure that improves the odds of the offspring surviving those first vulnerable days. After mating, the female lays her eggs right at the center of the completed circle. By some observations, the male stays nearby for several days while the eggs develop, though how much he's actually involved in guarding the clutch at this stage is less well studied than the construction process itself. And sooner or later, the circle gets washed away by the current, and everything starts over from a blank slate for the next cycle. It's worth returning to the question raised at the very start of this story. What if the creature we fear isn't what it appears to be at all. A relative of fugu, belonging to the same pufferfish family and using the exact same defensive biology, the ability to inflate and to accumulate tetrodotoxin through contact with the right bacteria, turns out to be the architect behind one of the most elaborate examples of nonverbal courtship known to science anywhere in the animal kingdom. And to understand what actually connects this tiny architect to that deadly fish served in a restaurant in Shimonoseki, we need to bring both stories together. The fugu served in upscale Japanese restaurants and the tiny circle builder off the coast of Amami-Oshima aren't the same species. They're different members of the same pufferfish family, a group that includes more than 100 species worldwide, ranging from the commercially harvested takifugu, known for their deadly delicacy status, to a wide range of much smaller, far less studied relatives, including Torquigener albumaculatus. But every member of this family shares certain traits, inherited from one common evolutionary ancestor. All of them can rapidly inflate by swallowing water or air, turning into an awkward, hard-to-swallow ball, with spines or without them. That's a basic defensive reaction shared across the whole group. And in many species within the family, given the right symbiotic bacteria in their habitat and diet, that same tetrodotoxin defense discussed earlier can build up as well. In other words, potential danger is a shared trait across the whole family, inherited by all its members as part of one evolutionary survival strategy. But what that shared biology actually turns into for any given species depends on the ecological niche it occupies. The larger takifugu, living in environments rich in mollusks and bacteria, accumulate enough toxin to become lethal to predators and, as a side effect of human curiosity, to become a cult delicacy. While the much smaller Torquigener, living on sandy shallows, channeled just as much of its biological ingenuity into something else entirely. Painstaking, almost artistic construction that became just as effective a tool for reproduction as poison became a tool for defense in its larger relative. What emerges is that the same evolutionary starting material, a body that can inflate, skin that can accumulate a lethal toxin, plays out completely differently across different members of the family, depending on what problem a given species is actually solving, surviving itself or securing a future for its offspring. In some species, that starting material becomes a weapon of intimidation that, almost by accident, turned into an object of human culinary obsession. And in others, it becomes the foundation for one of the most elaborate examples of instinctive construction in the animal kingdom. One whose key tools turn out to be not spines or poison, but fins, sand, and persistence. But if the same underlying biology, shared by one group of fish, can turn into either a lethal weapon or raw material for art, what does that actually say about the very word danger? The label we've so confidently pinned on fugu since the beginning of this story. Answering that question is what finally brings both stories, the restaurant in Shimonoseki and the circles off Amami-Oshima, together into one picture. Now it's possible to answer the question that closed out the last chapter of this story. What the word danger really means, when the same biology turns into death in one case and art in another. And it's also time to return to the two big questions raised at the very beginning. The first question was about why people are willing to pay for risk with pleasure. Fugu culture in Japan is a story of institutionalized, carefully controlled risk, not a story of recklessness. Centuries of bans and permissions, years of training for chefs, government licenses, and, at the end of it all, a guest's confidence that the fish on their plate is safe, precisely because an entire system of oversight stands behind the chef who prepared it. and people are paying for the chance to legally brush up against mortal danger and walk away from the table alive. For a controlled experience of the line between safety and risk, one that stays sharp even when there's almost no real threat left. The second question was about what's really hiding behind the reputation of a dangerous creature. The answer that the story of the Amami-Oshima circles gives us is more interesting than a simple takedown of a scary reputation. It unexpectedly echoes the first question of this story, the one about risk at the table in Shimonoseki. A male Torquay Jenner takes a risk too, just a completely different kind. For more than a week, he spends nearly all his strength and energy building a pattern, with no guarantee at all that a female will choose his circle over a neighbor's a little further down the sandbank. And it isn't the risk of dying from poison. It's the risk of wasting a meaningful chunk of a short life if the work goes unnoticed. What emerges is that the hero of the restaurant in Shimonoseki and the hero of the sandbanks off Amami-Oshima are taking risks for different reasons and over different things. But underneath both stories sits the same basic bet, a chance that might not pay off, but is worth taking anyway. Both stories, the restaurant in Shimonoseki and the underwater circles off Amami-Oshima, are, at their core, telling the same story from two different angles. The idea that the same underlying biology can become either a source of fear or a source of wonder, depending on the task evolution assigns it. The Fugu people fear, and the Fugu that builds, are different species within the same family. But together, they're a reminder that behind nature's most frightening reputations, there can be a completely unexpected, far more human story. If the story of the deadly delicacy and the culture of risk in Shimonoseki is the one that got you, let me know in the comments. Would you actually try Fugu now that you know everything you know about tetrodotoxin? And if the story of the tiny architect off Amami-Oshima is the one that moved you more, hit like and tell me which other animal you think deserves the title of the most underrated master builder in the wild. I read every comment and I'll respond to the best theories.